Hello, myself Dr. Mohammad Muqeed, working as Assistant Professor in Chemistry, Marri Laxman Institute of Technology and Management. Today I am discuss about the one of the topic of engineering chemistry, second module battery. These are the contents today I am discuss. Introduction of battery, battery's characteristics, battery types, primary cell, secondary cell. Next, what is battery? Battery is a electrochemical device that converts the chemical energy to electrical energy. So, first of all, Benjamin Franklin in 1749, first word of battery he was invented when he was studying in the batteries in the electricity. Then he is the scientist of American scientist. Then onwards, Benjamin Franklin, after Alessandro Volta, invented the first word of real battery. In the century 1800 century, he was first used the battery word. Next, battery is a device that changes the chemical energy into electrical energy. Next, what is the parts of battery? Battery consists of three parts mainly, that is the negative electrode and positive electrode and electrolyte and porous separator. This is the image, this is the figure. Negative electrode, positive electrode and electrolyte and porous separator. When you are connected something to the battery, when you are connected something to this battery, it allows the electrons flow. What happens when the electrons is flow? The create the electricity. Next, some of the characteristics of the selection of good batteries is it should be compact. Compact means small, fit in the space what we have. That means a battery is physically very small and fit into a limited space. For example, we are in a smartphones or wearable devices. The physically the battery is a very small, but it works is very well in the wearable smartphones and wearable devices. Next, it should be supply for power for long time without needing any space. It will be without needing long time it will be running. Next, for example, we are taking the solar power calculator. It will work so many weeks. Next, it should be rechargeable. That means it will be able to them recharge again and again. It will be able to recharge again and again. Next, it should be have capacity. That's mean able to store the lot of energy in the batteries. So it should have the high efficiency. That means its energy is used wisely and not wasted a lot. For example, in a battery have low internal resistance. It's allow the efficiency energy. It's the transfer the efficiency energy. Then what happen? It reduce the heat loss and extending the battery lifespan also. Next, what is the battery efficiency? How to calculate the battery efficiency. Efficiency is the measure that how well battery is convert the energy, how well battery the convert into the energy when the time of during the charging time into usable energy when the during the discharge time it will be it will deliver the energy. So how to calculate the battery efficiency? If you want the battery efficiency percentage, we are multiply with the 100. Multiply with the 100. What is the formula of calculating of battery efficiency is energy released and discharge by energy required discharge multiply with 100. For example, if we take the some values of following characteristics, energy released and discharge is 500 joules and energy required the recharge 600 joules. Using these values in this formula, 500 joules by 600 joules multiply with 100, it will become 83.33. This is that means 83.33 is the battery efficiency. If you take 100 percentage in 83.33 means remaining 16.77 percentage nearly, it will lose some energy. That means the battery have 83.33 percentage efficiency that battery having. Remaining 16.77 percentage nearly, it is the last the some energy. So we can say that 83.33 is the battery efficiency. This energy during the charging and discharging process time is we are calculating in this formula. But still this is the quite efficient percentage of battery. What is batteries? Two or more electrochemical cells are interconnected in a series that used as a battery. In a battery consists of two or more groups or electrical cell connected together in a electrical series, and battery has a portable source of electrical energy. And batteries are classified into mainly on the capability of the recharging capacity. We are dividing into three types. First one is primary cell, second is a secondary cell, third one fuel cell. These primary cells are called as primary batteries also called. These secondary cell also called secondary batteries. Next, primary batteries. Primary batteries are called as non-rechargeable cells also called. Now these are the non-rechargeable, we cannot use again and again. That means this is the one time this battery is using after we are throw away. Next point, the single use, that means the only one time is using. These primary batteries are using only one time. Discard after use, that means we are using one time after we are throwing away. Non-reversible action, this chemical reaction inside the battery cannot be revised. Once the reactant convert into the product, in this primary batteries, one reactant convert into the product, it will be dead. Again, the process is not reversible. Only one time only use these primary batteries. Next, these primary batteries are less expensive. That means very cheaper than the rechargeable battery. For example, ordinary gadgets. These are often used in flight lights and watches and ties. We are using these primary batteries, flashlights and watches and ties. And these primary batteries are provide the direct current. Example of primary batteries is zinc air batteries. Next, zinc air battery example we are discuss here. Zinc air battery construction, working and principle. Mainly zinc air batteries consist of mainly three parts. That is, the battery has zinc metal anode and air cathode. Third one is electrolyte. In this battery, zinc metal anode is a negative charge. This cathode is a positive charge. And this electrolyte help the electronic flow. This is the zinc metal anode is a negative part, air cathode is a positive charge, and electrolyte. This electrolyte is separating the positive charge and negative charge. These electrolytes help the electronic flow. This electrolyte is made of the hydrogen, potassium hydroxide. Next, oxygen. What is the role of oxygen in the zinc air battery? Is the oxygen from the air the battery enter with the help of air, the oxygen absorb the cathodic wave. This cathode, through the cathode, the oxygen from the air is enter into the battery. The what happened, the chemical reaction when the zinc and oxygen react and produce the electricity. During the discharge time, when the battery is used, these zinc particles form the porous anode. And next, this oxygen from the air react with the zinc and creating the hydroxyl ions. These ions moves from the electrolyte, combines with the zinc to form the zincates and releasing flow of the cathode and producing the finally electricity. These are the image of the zinc air battery. This is the parts of the battery. There are three main parts: zinc anode and electrolyte and separator, and the third one is gas diffusion electrode. This is the air cathode. This is the positive charge, this is the negative charge. This is the electrolyte separator. This zinc anode is negative charge. Zinc anode is a negative charge. It is a made of zinc metal. This is the made of zinc metal. And electrolyte, this is the electrolyte and separator. The layer of separator, zinc anode and the air cathode, it also contains the electrolyte, which helps the electricity flow. It helps the electricity flow. Next, gas diffusion electrode. It is a positive part of the body. It's allow the oxygen. From this side, showing in image, the oxygen. This is the positive charge. It's allow the oxygen from the air enter into the battery. Overall reaction is zinc react with the oxygen. This zinc is react with the oxygen through the help of electrolyte and form the zinc oxide. When the battery is used, zinc metal and anode react with the oxygen, then they produce the electricity. The application of the zinc air batteries is main application is power sources, like used in a power devices like hearing aids and medical devices and pagers, and temporary power packs also using the zinc air batteries. This can be used as the temporary power source for the mobile phones, and we are using mainly important role in a military and communication purpose also. Zinc air batteries are using. They are military radio receivers and voice transmitter and road signaling. These are the main application of the zinc air batteries using in a military communication purpose. Very useful these zinc air batteries. And the advantages of this zinc air battery is the safety environment benefit. It is a very important to remember that it is a safest for, it don't harm the any nature environment, and it is a good shelf life. It can be last long time without being using. It will be used the very long time also. And these are the zinc air batteries is the low cost, low relatively other compared to these batteries are very low cost, and these are the high energy density. That means they store the lot of energy compared to the other primary batteries. Next, secondary cells, also called as rechargeable cells. Rechargeable, that means we can charge the again and again. Once the battery, for example in our mobile, we are percentage 100 to 20, then we are charging and we can use multiple times with the help of charger. This is the secondary battery. We are very useful nowadays every time. In next, reversible reaction. This reaction inside the battery is the reversible, using the direct current in a opposite direction. When we are using the chemical reaction in a battery, the direct current in a opposite direction, the reaction is called reversible reaction. And these reaction is many cycles. They can use the many cycles after discharging and charging. We can use the many times with the help of charging and discharging times. Now high capacitance, they can store the lot of energy. And long discharge, that can provide the flow electricity is the long time. Here the electricity is the long time we can use. And they provide the direct current. They can provide the direct current. Example of secondary cell batteries is lithium ion cells. These are commonly used in a smartphones and laptops and electrical devices. Lead acid storage cell. These batteries are used in a cars and other vehicles also. Nickel cadmium cells we are using. These are the common cordless phones. But they have largely replaced replace of lithium ion cells. Nickel cadmium cells are using. Lithium ion battery, which are the rechargeable battery commonly used in smartphones, laptops and other electrical devices. And what is the structure? Main structure of lithium ion structure is there are the main three types. Here the consist of porous carbon, and these porous carbon have the negative electrode or anode. This lithium metal oxide is the positive electrode at cathode. And second part is separator between the electrodes. This separator is separate with the positive electrode and negative electrode. This role is main is separator is this is a separating of positive electrode and negative electrode. This separator is usually made of lithium polymer gels. These separator only allows the ions through the separator, but not allow the electrons. The main role is separator is only it's allow the ions, not the electrons. But cell reaction, when what happen when the battery is discharged? When the battery is discharged, then the ions are released from the cathode to anode along with the electrons. Then what happened in a anode? When the battery is discharge time, these lithium ions are released and form the carbon anode. These electrons are also released from the anode side. The combination reaction is following this. And at the positive electrode cathode side, the lithium ion anode travel to the electrolyte. This anode is traveling with the help of this electrode then the electron flow. What happened? Anode to cathode with the external circuit. What happened in the cathode? At the cathode side, this lithium cobalt oxide form the low lithium cobalt oxide with the more lithium cobalt. The chemical reaction is lithium cobalt oxide and the finally form the lithium cobalt oxide. Finally form the lithium cobalt oxide. Overall reaction is when the what happened? Lithium cobalt oxide, this is the breakdown time. The cobalt oxide is less cobalt. This is the less lithium cobalt. This is the less lithium. This is the less lithium, and lithium carbon is this is the lithium carbon. This is the less lithium cobalt. Then during the discharge time, lithium ion batteries, and then what happened? These lithium ions move from the anode to this lithium ion moves from anode to cathode side. What happened? The electrons flow from the anode to cathode through the external circuit. Through the external circuits, the ions move from the anode to cathode the process, then the produce the electricity. Finally, the process produce this electricity. Once look here, the electrons flow from the anode to cathode. Then with the help of electrolytes. Here electrolytes made of the gel poly. This is the separator. This is the anode part. This is the cathode part. This is during the discharge time. During the discharge time, these ions are moved from this cathode to anode to cathode. During the discharge, this discharge time, electrons are moved from anode to cathode. And during the charging time, the electrons moving from the cathode to anode. What happened? During the discharge time, electrons moving from anode to cathode. During the charging time, the electrons move from the anode to cathode to anode. Then what happened? It's produced in this process, it's produced the electricity. This is the advantage of lithium ion batteries. Lithium ion batteries are high voltages and lightweight batteries like power hoses. They are strong and light. Perfect devices like phone and laptops are the examples. The key give the lot of energy. So these gadgets can work from the long time without running out. Next advantages, it is a smaller in their size and it's produce the 3 times of voltage nickel cadmium batteries. What is the applications of its lithium ion batteries are used in a cell phones and laptops, portable LCD TVs, and used as the semiconductor drive IDOs also. And these lithium ion batteries are used in a calculators also. And it's a medical field like cardiac pack makers also using the lithium ion batteries. These are the references what I am taking in these batteries. Some of the references taken from these topics. Thank you.